Understand? So, by using nodal voltage analysis and by applying KCL law, we are going to find out. We are going to find out the current that is passing through the branch. Okay, that is the current here. It's the current I1. Here the current will be I2, and the third element that will be I3. Okay. First step, what you have to do is you have to mark the node. Okay, the node is what? The point where the elements meet. Okay, so what you have to do? You have to mark the nodes. How many nodes are here? One node here. Okay, and now next thing what you have to notice there. This is also considered to be a node, but we won't mention that. Okay, but still, what you have to do the next step. First, you need to identify the node. Next, what you have to do? Maximum elements. Okay, the maximum number of elements are connected to which node you have to see. Here I have taken for your simplicity, I have taken only single node. So the single node is take that as reference node. If one more node is there, means what you have to, I will teach you the next sum with one more node. Okay, so maximum number of elements is connected to which node you have to see. Okay, maximum number of elements connected to which node, that is considered to be as the reference node. After identifying the reference node, since it is one node, we have to take that other end as the reference node. Okay, so just assume this as everything you have to do what? Assume. In order to calculate the current, we are going to assume the flow. Okay, so let's take this as reference node. After identifying that reference node, the next what you have to do, you have to connect it to the ground. Okay, if any terminal that is connected into the ground, means the voltage here it will be what? 0 volt. Okay, so that particular node, the reference node which is connected to the particular node, from that the current will leave. Okay, since it is current, it will go to ground, right? So we are assuming that all the currents will leave from this particular node. Okay, this is all your assumption. By this only we are going to solve this circuit. ಇದೆಲ್ಲ default ಎಲ್ಲ ಸರ್ಕ್ಯೂಟ್ ಫಸ್ಟ್ ಇನಿಷಿಯಲ್ ಮಾಡೋಣ. Okay, first step to identify the node. That is next step to find out where the maximum element is connected to a particular node. And the node எடுத்து என்ன பண்ணனும், அந்த நோடுக்கு நேர் கீழ இருக்கிற பாயிண்ட you have to assume it as reference node. First, node identification. Second, maximum number of elements to that which node. That other end of the node as reference node, that has to be grounded. That grounded, there will be a 0 voltage. So since the current is passing through the ground, we are taking in the reference node to the ground, and the point left, we are assuming that the current is leaving away from that point. Okay, the current is leaving away from that point. Okay, so now how can we the current will be as I1 in our order, I1, I2, I3. Now it is shall we say now? So this I am marking here, since it is one node, I have taken this node voltage as V1. Okay, and here it is given 6 volt, and here it is given 12 volt. What I want to apply? I want to apply, since there is only one node, I am going to apply to that particular node only. So apply KCL at node. We have taken one node, so at node 1. Okay, so since all the current are what doing, it is leaving at the node 1. So we will be putting as minus I1, minus I2, minus I3 is equal to 0. Or we can say this all minus 1 will go to the right. We can go, how can we write it? I1 plus I2 plus I3 equal to 0. So all the three currents are leaving. Current leaving is equal to current water entering, right? Here all the current are leaving only. So all will be coming in the one side. So we can take it as I1 plus I2 plus I3 equal to 0. The minus I1 எல்லாமே leaving, that are leaving, நான் minus பண்ணா எழுதுறேன். அப்படி நீங்க கெஸ் பண்ணனா write it as first நான் அந்த மாதிரி minus I1 minus I2 minus I3 equal to 0. For our convenience, if it is in plus, so take that to the right hand side. I1 plus I2 plus I3 equal to 0. It will be more easier. Minus and the common multiplication and that we can avoid that, right? So we have assumed that I1 plus I2 plus I3 is equal to 0. Now we have to know what is the current I1. The current is I1 passing through the resistance 2 ohm. Right? So we are looking at the node V1. So I1 is V1. We are looking at the node V1. So V1 minus, who comes here? We are measuring here, right? Across this, what it is. So it is 6. V1 minus 6. The resistance across line it is R1. The value of R1 is 2 ohm. This is the current I1. Can you able to understand? I1 is coming from V1 minus 6 divided by 2. And next, I2. I2, the current going from only the node V1 alone. So, here whom we are applying, how can I write that I is equal to V1 minus 6 by 2? What is the formula here? Here we are applying Ohm's law. And we know that I is equal to V by R. I am applying I is equal to V by R. I want to find the value for current in the branches. I want the value for I1, I2, I3. So I am going for the Ohm's law. By Ohm's law, I know that I is equal to V by R. Here there is two voltage. What is the node voltage? And there is the source voltage is there. So since I am considering the load as voltage reference taken, that is we are writing it as V1 minus the source voltage 6 divided by R. The value of the resistance R is 2. So we have written I1 is like this. Clear up to this? And next one is I2. I2 is the current flowing through the resistor of value 4 ohm. Okay, resistance of value 4 ohm. Here the voltage is only go with the, it is connected to only the node, right? So I2 is equal to V1 by the value of the resistance 4. We don't need to minus out all that because the resistance is not connected to the source. Here the resistance one end is connected to the V1 and the other end is connected to 6. So what have we done? V1 minus 6 by the resistance value 2. Here it is the two terminals of the resistance are connected to, one is V1, other one is ground only. So if you want to put that, you will be putting it as V1 minus 0 because other end is what? 0. Okay. So no need to mention that. V1, if you want to put means also it will come like V1 minus 0. No need to mention. Just V1 by the resistance 4. Clear up to this? Next, I3. The current to this resistance. Okay. What is here? V1 minus 12 divided by what is the resistance value? 6. Okay. Now shall I substitute this? This is equation number 1. I have to substitute the value of I1, I2, I3 in equation number 1. Okay. So it will become V1 minus 6 by 2 plus V1 by 4 plus V1 minus 12 by 6 is equals to 0. So now, shall I separate it like V1 by 2 minus 6 by 2 plus V1 by 4 plus V1 by 6 minus 12 by 6 equal to 0. What are you going to do? 1, 2, 3. Numerators we are going to cancel. 1, 2. Okay, and I can take all the V1 as common. So what will be the same? Plus 1 by 4 plus 1 by 6. What will be minus? Minus 3 minus 2 will become minus 5. Okay, so now if you take LCM, what will be here? The LCM will be 12. So it will become 6 plus 3 plus 2. So I take this minus 5 to the right hand side. This is minus 5 plus 2. So I take this minus 5 to the right hand side. So it will become become 5 plus 5. So next it will become V1 into, if we add it, this means 12 by 2. What is the value for 12 by 2? Okay, just okay. V1 is equal to 12 into 5, that is 60 by 11. What's the value for 60 by 11 then? 5.45. Just 2 decimal point 7. What is the voltage value there? 5.45. Now shall I substitute that in I1, I2 and I3? Shall I find the branch current? That is. What is the value for I1 then? I1 is equal to V1 minus, that is 5.45 minus 6 divided by 2. What is the value for it? Minus earlier. How? 5.45 minus 1 is minus 0.27. Minus, if it comes in minus, you should put that as minus. You should not change that minus into plus. I will tell you that why. Okay, now listen. So if it is minus, put that in minus. So the value of current is minus 0.27. Okay, unit of current in amps. Okay, and next the current I2 is equal to what? V1 by 4, right? Is equal to 5.45 by 4. Value is 1.36 amps. Clear about this? Next I3. What is the value for I3 then? Okay, substitute that is 5.45 minus 12 divided by 66, that is equal to minus 1.09 amps. Okay? Up to this you should just stop. Right, for your understanding, I'm saying that if this value is in minus, we told you to put into minus, right? But in the previous one, I have added one more point, right? Drawing the actual circuit, actual flow of current. You don't need to confuse with that. Just to draw this diagram, assume the flow of current like this. Just enter the value in minus. That's enough. Okay. Now listen. Actual flow of current. For your understanding only, I'm saying no need to confuse with that. The current should flow in this direction, right? It will show us flows in the clockwise direction, right? So it is in minus. So reach correctly, right? Actually, plus but now assume opposite assume so minus opposite or likewise I2 will flow like this, correct? I2 will flow correct. So it is plus. Okay. So likewise I3 it should flow like this, right? So that it comes opposite. So for your verification I told you don't need to solve it. Just to draw the circuit. Step 1, identify the nodes. Step 2, what you have to do? You have to see how many maximum number of elements connected to a node. Take that as the reference node and then ground it, and then what you have to do? 0 volts. Okay. So since it is 0 volts, the current power flows. We are assuming that the currents are flowing to that. So assuming that the currents are leaving away from that particular node. Clear? So after leaving, what you are doing? You are applying KCL. Then by applying KCL, then you have to apply the Ohm's law. If you solve mathematically, you will reach the answer. This is a procedure. This is a procedure for all the sub. Even one more node is there. Based on the reference node, you will be solving the problem. Okay. So, step 1, what you have to do? First step, identify the node. How many nodes are there? 2 nodes. 2 major nodes. This is also what? This is also nodes, and we also connected as both are connected to the same point. So, okay, and now what you have to do? You have to next step what? Maximum number of elements. If you consider this both the nodes, both are connected with the same number of elements, right? So take the first node as reference node. Just mark this is node number A and this is node number B. and this is C, and this is D. Okay, if the elements are equal on both the node means just mark the first node as reference node. Okay, clear up to this. Next, what do you have to do? Reference node identification of the current is leaving away since it is 0 volt, since it is grounded. Clear up to this? Next step. What do you have to do? You have to apply KCL at node A. Okay, so while you are applying, we can say that all are leaving. So we can say that I1 equals to 0. Okay, and now you have to know that what is that I1. I1 is what? V1 minus V1. Here I have taken as VB. Or you can take it as 1, 2. Okay, so we will write it as VA minus 12 by 2. Clear up to this? The next I2 is equal to VB. I2 is equal to VA by 3. What is the rest there? 3. Clear. And next I3. What it is? VA minus VB. VA minus VB by 4. So solve and tell me result. Just substitute in the, take this as equation number 1. So substitute all the I1, I2 and I3 in 1. So how it will be? PA minus 12 by 2 plus PA by 3 plus PA minus by 4 equal to 0. Okay, and then solve this. That is VA by 2 minus by 2 plus VA by 3 plus VA by 4 minus VB by 4 is equal to 0. Next, 1, 6. Is there any numericals? No. So, if we take VA common outside, 1 by 2 plus 1 by 3 plus 1 by 4. And in between there is VB by 4 equal to 6 minus 6 comes here, it is 6. So, if you take LCM, what is VA then? 11 by 12. Then it is 11 by 12 is what? LCM is 12. Okay. Next, what you have to do? LCM is 12. 6. 11 by 12. So solve and tell me that 1 by 2 plus 1 by 3 plus 1 by 4, what it is? We need to take the LCM or just put it in the calculator. VA into how much it is? 13 by 12. Divided 1.08 VA minus 1 by 4 is 0.25, right? 1 by 4 is what? 0.25. VB is equal to what? 6. So, take this as equation number 2. Okay, now apply KCL at node number. Apply KCL at node B. Okay, so here, how will be assuming the current flow of current means? So this is reference node, right? So already the current I3 is moving here. Here it is marked as I1, here it is I1, I2, I3. So don't disturb this I3. Okay. The other rest of the thing is the actual flow of current. Okay. How it will be? I will flow this direction, and one more current will come here towards the down, right? Up to which we have marked I3. So the take the next is I4. and the next to it as clear. Now this is the node BB. Shall we apply KCL at node B now? How we can write that? Entering characters I3. Okay. One more entering characters I4. The leaving characters I4. I3 and I5 I4 leaving. So shall I write it like this? I3 plus I5 minus I4. I4. Right? So shall I take all this to the right hand side? So it will become I4 minus I3 minus I5 into 0. So it will be easy if it is in order. So write the I3 first. I3 is what? Minus I3. I4 is plus I4 minus I3 equal to 0. And what is the current apply? Now what you have to do? You have to apply the Ohm's law. So minus of what is the current I3? I3 is coming from where? VA minus VB. VA minus VB by what is the resistance there? 4. Okay. Next to the sign is plus. What is I4? I4 will be that no voltage. That is VB by 3. What is the next step? That is minus of. What is I5? VB minus V2, right? What is here? 15, right? That is VB minus 15 by 5. 15 by 5. What is the resistance there? 5. Is equal to what? 0. You all clear up to this? Shall we solve this equation? Solve it, and next one you will be receiving an equation like this. Okay. And now take the calculator. Do you know how to solve the equation in calculator? That's a mode equation. Mode. Do you know that? I tell you that. Now solve it for equation.